Okay, now I'm going to share the screen. Can you see it?
Yeah.
Okay. All right. So, you know, I think the lesson two start with talking about what's the variables, what kind of data, what type of data is available. You know, it's often used for statistic analysis, and it's important that you could distinguish what's categorical variable versus quantitative variable. Here I give you some example. So categorical variable is something like it's hard to break into a series number. Okay, for example, like car brand. So each car brand is distinctive, could be distinguished from each other. And type of Halloween candy and gender, female and male, they are individual category, and all different kind of disease, those type of something is usually considered categorical. And quantitative variable is something that it have continuous features. For example, like age, from infant from 0 to 100, it has a continuous features. That's why sometimes it's called continuous variable. And test score, is a continuous feature. It can range from say 100 to 400, right? And also the weight and height and price. Price could be because some price, like for clothing, can range from say 10 to thousands. So they have continuous features. So those usually are considered as quantitative variable. And also another way to help judge is that, okay, if you take an average of that variable, does that make sense? So we can say average age, average price, or average test score. It makes sense to people. But when we say average car brand, it's kind of strange, because how could you break down brand? If you say 1.3 average car brand, it's kind of doesn't make sense. So this kind of like characteristic can help you to distinguish what is categorical and quantitative variables. And why it is important, because knowing what type of variable you have would determine what kind of statistic method or statistic testing technique you want to apply. Okay. Do you have any question about this? No. Okay. Then we'll move on. And I think you also in the curriculum provided on the online textbook, you also introduced about about what is observational study and what is experiment. And the way to distinguish these two is that for observational study, that is that is a kind of design that you observe the change or the existing phenomena of a sample. For example, researchers collect a group of elementary school students face like their immune records and other medical records, in the same period of time and compare their frequency of getting a cold based on their, immunization records. So this is like observational study. Okay, you collect data, you didn't make any control. That's observational. But experimental study meaning you try to control a treatment, okay, on different group of students in this case. So in this case, if you want to do experimental studies, then you will have to have two groups, randomly select two, say 20 students, and then divide them into two groups. One group in the same period of time, they didn't take any immunization at all. The other group, they all took the same kind of the same kind of shot. And after probably 2 or 3 months, you collect data, and then you collect the data and compare what's the difference between these two groups. Then this is an experimental study. So there is a treatment there. The treatment is the, whether the student get an immunization shot. Okay, so that's how to distinguish these two. Okay, and what is the population? What is the sample? I think this is kind of easy because the sample is basically a small group collected from a population. For example, the total fish from a pond is a population, but you cannot do experiment or do some testing on every fish from the pond. So you basically collect only say small portions of fish to do the experiment, and this small portion of the fish is a sample. Okay, so that's the difference. And what's the difference between parameter and statistic? Parameter is the actual number drawn from the population, so the whole populations. And for example, the F from the whole population is a parameter. Okay, the mean age of employees in Salt Lake City is a parameter. Okay, and statistic is the estimate, is from a sample. For example, if you randomly select on the street, randomly select 50 people, they walk on the street, and ask them about their age, and take a mean age of those employees in Salt Lake City, then that's a statistic because that's collected that's an estimate from the sample. Okay, so so these two terminology just based on whether they're population or they are a sample. Okay, and then we talk about sampling approach because it's very expensive if we want to collect data from a population. So the majority of time, besides US Census, those kind of big survey, the majority of time we collect sample data. And it's important that to do a precise estimation, it's important that we collect the sample that do not have bias. So there were different kind of sampling approaches that researchers usually use to collect data. And you will use those approaches for your final project too. The first one is called SRS, that's a simple random sample. So what this is do is that it's kind of like a random draw from of the lottery, those kind of stuff. So when you have say a group of observation records, and you want to draw a sample, say you have 100 people that you can collect data from, but you don't have those you don't have those budgets to collect so many informations. So you want to only collect 15 cases. So so each case you assign a number from 1 to 100, and then you put it in, you like randomly draw from a bag, and then get 15 number out from the bag. And this kind of sampling approach is called simple random sample. Systematic sampling is something like it's something like you select the samples in a systematic way. For example, you select sample every other 5 cases. Okay, and then you collect 20 draws from the pool. This is called systematic sampling. And I have some YouTube video if you want to take a look and then kind of get an idea about that. The cluster sampling is more like so you have different type of group of people. Say, for example, like you have like a different neighborhood, and you want to know what the residents' opinion about building a grocery store in the area, and they are like living in different type of housing unit, and you just select one type of housing unit and collect data from everyone live there. That's kind of cluster sampling. Oh, and then stratified sampling is more like, okay, there are different type of people, and for example, different racial peoples, and I want to know their opinion about what type of transportation they prefer to use for work. And so I separate them into different groups by their race, and randomly select, say, 5 cases from each group. Okay, so that's a stratified sample. You group people first and randomly select your sample from each group. And convenience sampling is the easiest way because it's just like whatever is easiest way for you to collect data, you use that approach. So you go to street and asking at a certain time and asking every passengers that walk by the street and asking them the question and collect data, because that's more convenient for you to collect those data. That's called convenient sampling. Okay. It's weird. It's called. It's telling me that remaining meeting times only have 2 minutes. So I wonder why. Oh, probably because it doesn't allow me to record the meeting so long. Well, let's continue. I can record it later. After you collect the data, then you make I think you guys started to get familiar of using Excel. So I just make up some data and demonstrate to you. So this is just a simple data. They show how many in my samples, what's the age distribution look like. So I have one person's age 13, 2 persons that age 14, and etc. And based on the data, I do a histogram distributions and to see how my data look like. So the y-axis is the frequencies, and the x-axis is the age. So then I could see, okay, the majority of my samples, their age is 15 and 16. Okay, and I will from this distribution, I can start to guess what's my sample mean, my fall in what age group. I was guessing maybe my sample mean will be between 15 and 16 in that range. Okay. So that's the purpose of running the histogram, kind of trying to show how your data look like. So, and then from the data you collect, then you would start to learn how to read the data and how to interpret the data. So from your data, for example, like this one. If I make those people stand up from young to old, by the age from young to old, and then to see the distributions first, and I trying to capture. So here I have 20 cases,